Good afternoon. Welcome to today's webinar, Proper Environmental Management of Industrial Equipment. During today's program, our presenter will cover the following. During today's program, the presenter will discuss the responsibilities of the equipment supplier, installing company, and user. Specifically, the presenter will cover the buyer's responsibility, equipment supplier's responsibilities of installing contractors, regulatory agency approval, notices of violation, strategy for reducing risk, and employee safety issues. Additionally, the presenter will provide insight into equipment performance and installation-related investigations, as well as methods to reduce risk. The presenter for today's program is Peter Millar. Peter is a registered chemical engineer specializing in environmental equipment performance and site selection. He is an advisor on issues involving international trade restrictions concerning hazardous substance, recovery of metals from mining operations, agribusiness processes, process equipment and pumps, environmental liability insurance, wastewater treatment systems, plating practices, residential construction remodeling, employee safety and health, and commercial contracts. We'll take 2 question and answer breaks during today's presentation. If you have a question, please use the chat or the Q&A feature located on the right-hand side of the screen to submit your questions. I've pointed out the location of the chat and Q&A features with my red arrow. We encourage all attendees to submit questions throughout the presentation. Tomorrow morning, I'll send out an email with a link to the archived recording of this webinar. We do ask that you take time to fill out the survey that will appear on your screen after the webinar is over. I now invite you to sit back, relax, and enjoy. I'm going to turn the presentation over to our distinguished presenter, Peter Millar. Peter, the presentation is all yours.
Super. Matt, I'd like to explain a few selected terms that I will use throughout this presentation. The responsibilities of the buyer, which is used in the header on some of the slides, is equivalent to that of the end user. In this webinar, I'll use the term end user instead of the buyer. An end user can employ separate personnel for purchasing and in operations who will contribute their time and knowledge. An environmental system supplier is a firm that can furnish all of the equipment, including control systems and engineering services. The supplier may also be responsible for the installation of their equipment. Environmental control systems are one example of a system that purifies a product using industrial equipment. Environmental control systems purify air and water to differing degrees by removing contaminants that also generate a byproduct, usually referred to as waste. Purification systems in general receive intense scrutiny by the public and government. Examples of these systems include drinking water systems, industrial process water treatment systems, for example, used in critical applications in the defense and aerospace industries, industrial or municipal sewage treatment facilities, and air emission control systems. This webinar will focus on various aspects of purchasing and installing environmental control systems. Please note that my comments will not address every bullet item in a slide. My intent is to clarify the topics that should enhance your understanding of the various responsibilities as described in this webinar. Our first slide asks who will benefit from understanding this webinar. They include those who counsel firms who may sell equipment, or who may transport equipment, or who would install equipment, or in fact anyone who operates an environmental control system, including independent contractors. A second opportunity would be those legal professionals who represent any individual who may feel harmed from exposure to a product or any byproduct, and who cites a component of an environmental control system as a potential contributor to any damages that may have occurred. The third opportunity would be for those legal professionals who represent a regulating agency, a lobbying group, or an NGO, which is a non-governmental organization. Go to the next slide, please. What are some of the responsibilities of the end user? Here I begin identifying topics and concerns that should be addressed throughout the process of purchasing, installing, and operating environmental purification systems. The sequence that I use to introduce each topic is not indicative of its order of importance. Individual concerns should be vetted internally by the end user and, when appropriate, discussed with outside technical service providers, chemical suppliers, legal professionals, and equipment suppliers. Occasionally, shortcuts are taken where some topics that should be discussed are not thoroughly vetted. Very infrequently, problems may appear due to results of topics not being thoroughly vetted or due to a miscommunication. A potential cause of a problem could be traced to a lack of personnel involved, the need to save time, or the need to cut costs. However, when problems occur that may affect or concern the environment, aquatic or other animals, or humans, regulating agencies, legal professionals, and the public can make life difficult through complaints, news releases, social media, investigation, and the threat of lawsuits. The end user's immediate responsibilities are responding to a regulatory agency when contacted to determine what will be required. They should assign in-house personnel to be responsible for the project duration and document all progress and communications. Each end user should be responsible for the safety of its own employees and contractors working for installers, and independent contractors that work on site. The end user should assess all known risks, such as reviewing situations that require immediate evacuation due to an emergency or a safety issue, such as during a fire or a loss of power. Next slide. Legal professionals, technical consultants, and suppliers are sources of outside assistance. These sources are called upon for advice and guidance regarding risks and deliverables. The end user should list acceptable risks and those that are unacceptable risks. Unacceptable risks may be reduced or eliminated by having standby equipment, standby procedures, or services available. One unique risk occurs when a supplier is selected to provide a proprietary product. Problems could occur if that supplier ceases production or can no longer provide that service for that product. Outside assistance can be useful for requesting guidance from manufacturing companies that supply equipment concerning any potential risk when they use that equipment or maintain that equipment. Outside assistance can also be useful when requesting guidance from in-house facilities personnel about risks from unanticipated weather and naturally occurring conditions, as we all have experienced recently, such as floods, earthquakes, tornadoes, hurricanes, excessive heat and cold, and sandstorms. Outside assistance, as well as internal assistance, can evaluate what critical items could fail during an interruption of power. If and when an environmental problem is anticipated, end users should be proactive by collecting samples and having chemical analysis available for review by outsiders or a regulatory agency should they ask for it. The end user should be able to define the average, minimum, and maximum loading from a particular source of material to be purified. Next slide, please. Outside assistance can be used to provide valuable advice beginning at the procurement phase. One risk to the production of a product could occur if an ingredient used to produce or purify that product is altered. For example, when the quality or clarity of your incoming water changes, the end user may have to alter their normal practice. In the unique case, when there is a water main break, the city or town should notify those affected end users. But, for example, in Santa Clara County, the municipal water supply combines both groundwater with water resulting from when the snow melts close to various reservoirs. Groundwater will generally contain a higher salt content than the water resulting after the snow melts. The contribution from each source may vary over time. An increased salt content may adversely affect the operation of a product purification system, such as a drinking water system or an industrial process water that requires high purity water in the manufacturing operations. Outside assistance can provide guidance on methods to address these issues. End users who produce a highly purified water for their production process may need a bolder system or a modified procedure to remove the additional salts when a change in the incoming salt concentration occurs. Outside assistance from technical consultants can, in addition to the last slide, provide opportunities to minimize the volume of waste to be removed off-site before requesting pollution control equipment. Again, by waste, I mean those contaminants that may be in the raw material used prior to a purification process. Outside assistance can comment on submitted proposals from equipment suppliers or others and independently assess the experience and actual response time of a proposed supplier. They could suggest when secondary containment and where a different floor coating could be applied to the floor under vessels containing hazardous substances. And they can address known safety concerns, including that which occur during an unscheduled maintenance procedure. Next slide, please. State and federal regulations and guidelines identify the minimum present-day requirements for an end user. Federal and state regulatory agencies draft regulations that are based upon laws to implement their programs. Legal, professional, and technical consultants should be advised if and when any regulatory agency makes contact with an end user. When companies expand, the expansion may be subject to environmental regulations not presently used. If an enforcement action by a regulating agency or when legal action is initiated by others, legal professionals must become involved. They will need to attend meetings, conferences, and follow the chain of communication that preceded the action. Each state has its own guidelines, rules, and regulations, sometimes involving numerous agencies. These regulations may involve acceptable plumbing materials, electrical requirements, and building codes. When a citation is received or when working with a regulatory agency, the end user should attend any meeting to become familiar with every requirement, every procedure, and to discuss dates for compliance or startup for their situation. One should ask the agency if engineering plans and equipment specifications need to be submitted before the equipment is purchased. You should ask if approvals for various items will be required for more than one agency. But remember, When the control agency issues an approval letter for a system, it is the end user of the treatment equipment that must comply with all of the requirements. Changing the subject, generally recognized best management practices include the need to assess methods to minimize cost, whether it be before or after new industrial equipment associated with environmental control system begins operation. The following list provides topics that be considered to reduce both cost and waste volume. Next slide, please. In this slide, I identify potential changes, steps, and improvements for the end user to consider in order to reduce their cost or minimize the volume of waste that may be produced requiring off-site disposal. Each major source of waste should be evaluated separately. Not every source in an end user's facility will use the identical changes, steps, or improvements to reduce cost. In fact, not every location producing waste will have a viable opportunity for a cost or waste reduction. This matrix method should be a cost-saving tool. Topics to be addressed in assessing ways to reduce cost include material input changes, operational improvements, production process changes, product reformulations, and administrative steps. Each step, change, and improvement can be rated using a matrix method by its feasibility to implement. For example, the end user could evaluate each potential process change, that's one of the changes noted in the slide, by rating various criteria, such as its expected change in the amount of generated waste. Will it be technically feasible? Will it be economically feasible? And what effect will it have on the product quality? This subjective analysis usually implies rating from 0 to 10 on the ease, for example, of implementing a specific change. The higher the rating, the more desirable that a specific opportunity can be implemented. Next slide, please. Before an end user issues a request for a proposal, which I will call by the initials RFP, the end user should first prepare a draft proposal in-house and review it with outside advisors. The end user should describe the situation that requires new equipment. What will be required? When it should be operational, and identify sources of the waste being produced. The draft RFP should state which unacceptable risks you want to avoid. Request suppliers to include pertinent employee safety recommendations to follow when using the supplier's or potential supplier's equipment. The RFP could suggest locations, if any, for any remote monitoring for alarm panels. And the RFP could include a request for a specific vendor of a programmable controller to interface with existing business process and monitoring systems. Discussions with legal professionals may include the need and cost for a performance bond. Legal professionals should have the final say on the end user's RFP before it is issued. Next slide, please. The following 3 slides include topics and questions for each supplier to address, and these should be identified in the RFP. Their response to the topics mentioned and answers to the questions asked will disclose which suppliers thoroughly know their own equipment and can follow instructions. As mentioned before, the RFP should identify every source of an emission or a discharge that may require remediation. It should include available plumbing and electrical locations, specifications, and if there are any restrictions regarding passage of the equipment to the job site. The RFP should state that critical spare parts be included in the equipment proposal being issued by each potential supplier. The RFP may suggest vendors commonly used at the site for electrical, plumbing, or other components. Next slide, please. In addition, the RFP should state the need for performance guarantee, and usually when that is required, one desires that the performance guarantee be better than present-day requirements. The RFP should demand that significant power-consuming equipment be energy efficient, such as when a pump motor is rated at above 50 horsepower. The RFP may include a request for estimated costs for power and other utilities on a monthly basis. It could also require that the selected supplier's technical personnel be available to the end user on a 24-hour, 7-day time frame or whatever is practical. The RFP should require that each item delivered have a physical tag attached to it for identification purposes. I'll describe a little more about this later. Next slide. The following list includes 2 items that are usually supplied with every proposal, but the entire list is what are finalized drawings and items that are only supplied by the selected supplier. These include a guide for operation, including daily operating log sheets, a process flow diagram, floor plan and installation drawings, a hydraulic profile, spare parts in addition to what was initially furnished, a subcontractor, vendor literature, and contact information for every component that is manufactured by companies other than the system supplier, and material safety data sheets when chemicals can be used within their system. Next slide, please. The next 2 slides provide a typical sequence of events before an environmental purification system can become operational. The actual time period for any project will vary on a case-by-case basis. In this particular schedule, the first slide talks about 8 weeks to define the quantities of waste and to assess steps, changes, and improvements to minimize cost and reduce any off-site waste volume. Following that, 4 to 8 weeks may be necessary to prepare a draft RFP, review and distribute the final RFP to potential suppliers. Following that, 6 to 8 weeks may be required to receive proposals and meet with suppliers. Following that, another 4 weeks may be necessary to evaluate and negotiate a contract. Suppliers should be offered the opportunity to collect samples used during treatability study prior to issuing their own performance guarantee. Next slide, please. This slide assumes that a vendor has been selected and that selected supplier has approved the purchase order from the end user that contains any accepted changes to the system's final proposal. So the equipment supplier has received authorization to proceed. They may need 18 to 20 weeks, which includes time to review and approve final drawings, materials of construction, and to receive all of their equipment. Following that, it may take 8 weeks to complete the installation. Following that, allow 4 to 6 weeks after the installation to bring the equipment online, conduct startup procedures, provide operator training, and to demonstrate acceptable performance to the end user. Next slide, please. The end user will assess all proposals received in-house, perhaps also requesting advice using independent legal and technical professionals. Following a thorough investigation of each supplier, the end user will select an environmental control system supplier for their application. The selection process should include discussions with each supplier, visiting similar operations by that supplier elsewhere, evaluating costs, and visiting the supplier's assembly site. Here are suggestions that are considered best practice by experienced professionals. They include selecting a system supplier and installing contractors after verifying their experiences at similar applications. Require periodic meetings with installers, independent contractors, to review progress and to discuss new, unanticipated concerns that may arise. One should anticipate how and when the selected supplier should demonstrate performance. I will provide a couple of options in the next section regarding the demonstration of performance. When appropriate, authorize changes to their in-house support systems following discussions with selected suppliers that would occur before any equipment arrives, and assess the need and cost associated with having standby electrical power, such as a generator, to operate critical components. Next slide, please. The end user must emphasize the need for communication and documentation. Written or emailed communication should be recorded in one place for each party involved, especially before any changes are made. The end user, along with the supplier and installer, should check, verify, and document that the system purchased arrives as quoted and as ordered. Support documentation provided by the equipment supplier should be distributed by the end user to in-house maintenance, production, engineering, and safety groups, or perhaps the one individual with responsibility for all those tasks. The last slide before our Q&A session provides examples of situations where legal professionals provided guidance, but after an incident occurred. The lack of communication contributed to those incidents. Next slide, please. A well-publicized example that disclosed a lack of communication concerns the Deepwater Horizon drilling rig oil spill during 2010. It appears that the lack of communication was a contributor to the fatal disaster. As Transocean continued its work on the well, even after encountering multiple hazards and signs of trouble, U.S. regulators suggest in recent weeks that British Petroleum's contractors, Transocean and Halliburton, may be targeted and fined. Legal professionals who advise insurance companies are certain to follow the situation. Transocean and Halliburton have consistently argued that their contracts with BP indemnify them against claims relating to pollution from the well. Now, are there any questions?
Excellent. Thank you, Peter. We do have a couple questions in the queue, and to all the attendees out there, if you have a question for Peter, please use the chat feature or the Q&A feature found on the right-hand side of the screen to submit your questions. Peter, this question comes from George. Do you have any, or have you seen in your consulting work any changes in how regulatory agencies are working with end users with environmental, with these large industrial products? Are you seeing any new environmental regulations come out, or is the approval process pretty continuous over all the states?
They will vary as a function of time over the many years, depending upon political and economic conditions. They're not stagnant by any stretch of the imagination, and discussions for specific projects with regulatory authorities may allow for expedited review of applications and expedited determination of enforcement procedures when it's appropriate, but that's on an individual basis. They are somewhat flexible. They're not always rigid unless it becomes a political issue that may be caused by the public being alarmed about a specific situation.
Okay, excellent. And now we have a question about the RFP process and the best practices. What's the best way that you found to keep the communication open and transparent between all the parties? And is there a way you should document that?
There should be a log. You should have a person who is assigned the whole project. That person or team may include individuals who will monitor the progress by having most communication be copied to everyone concerned. There should be someone who can coordinate what's going on, such as a project manager that may be the end user's project manager, the equipment user's project manager, who should be technically qualified enough to interpret which requests and communication should be documented. But as much documentation as you can have, the better off you are, should any condition arise that would question procedures that preceded an incident occur.
Okay, and a follow-up to that, and this will be the last question during this Q&A break. What are the most frequent problems that you see in the RFP process? Where does the confusion come in, and where is most of the litigation centered?
Litigation is generally a result of misinterpretation. If communication is lacking between an equipment supplier and the end user or an installing contractor who follows an RFP that doesn't require perhaps weekly meetings, there could be problems that occur requiring some kind of action on either party. Communication is key, and in trying to sit down with people in face-to-face basis, some disagreements or misinterpretation should occur. The RFP, there are standard forms that may be available by looking online what is required, but the buyer or the end user may want to ask for representative RFPs that they have received in order to determine what should be required to be in their own RFP. I've identified most of the topics. There are many issues that come up that may involve limited liability of a supplier that may have to be discussed or outlined in the RFP. But the RFP should be basically a document that says, hey, I have a problem. I don't know the solution to the problem, but I know I know what is required as a result of solving the problem. And it should describe the concerns produced within the end user's company. What are their liabilities? What are their risks? What are unacceptable risks? What are acceptable risks? These things should all be outlined and then presented in the RFP as saying these are concerns that we'd like you to address, either through meetings or through communication of some other sort, such as written communication or email.
Okay, I don't see any other questions in the queue, so let's continue on with the presentation of content.
Okay. The second half of this webinar will describe some of the responsibilities of equipment suppliers, installers, and independent contractors. The most common safety issues will be described. So let's begin. Potential suppliers provide proposals containing a description of their purification system and identify their on-site assistance. The supplier's goal is to meet all the objectives and address concerns that are identified in the RFP. That's why the RFP is fairly important, but it's really a stepping stone for continuous communication. Every situation is fluid. While an RFP may be issued, the actual requirements may change over time as more is discovered about a particular project or particular opportunities to perhaps reduce the waste volume. Proposals generally include, these are proposals from the equipment supplier, a description of the technology proposed, the chemistry involved, a schedule for equipment delivery, and if included, installation, various costs, the terms of payment, useful references for the end user of similar systems provided by the equipment supplier, and the equipment return policies and business procedures. I think that each proposal should identify the names of individuals along with their CVs who will provide telephone support and the people who will provide on-site services. As I previously mentioned, the end user assesses all proposals received in-house, and hopefully that's true. Following a thorough investigation of each supplier, the end user will select the supplier for their application. For example, the supplier should understand what the RFP contains. If there's any questions, they should ask them. Clearly state if there are any exceptions to what was requested in the RFP. If an exception is taken, provide an alternative option. The proposal or the request for proposal may include a performance guarantee, and if so, the supplier should identify how that will be verified in the field. The selected supplier must check, verify, and document that all items purchased by the system supplier has been properly ordered and has arrived at their own assembly area as specified by that supplier. Next slide, please. When practical, every potential supplier should inspect the end user's facility and discuss issues that may not be clarified by the original RFP. And that assumes that this site is this assumes that this site is not a yet-to-be constructed site before issuing a proposal. Each potential supplier could recommend who will be responsible for the collection and transporting materials to a central or alternative locations site for purification. After an equipment order has been received, the selected supplier should revisit the site to describe what modifications, if any, will be required to any location before the equipment arrives at the job site. At that time, the selected supplier should thoroughly review the detailed proposal again to determine if further clarification is required. Again, this is a continuous communication process that I recommend is best capable of minimizing any problems that occur. The selected equipment supplier should keep the end user informed if, and document when, any equipment listed in their proposal is no longer available, will be late, or if a component must be substituted in place of one that is defined in the proposal. In addition, a site inspection can detail any possible what OSHA requires or has defined as a permit-required confined space or a restricted space condition. The on-site inspection could or should look at a receiving dock and access to the job site. Will the equipment have to be sized so that it can fit within a 6-inch wall space where a door is located? They should assess any emergency evacuation needs in cases where there are below-ground pits where equipment is located during the installation process, or even when the equipment arrives. You may have a situation where an emergency exists and you have to immediately evacuate the people in the pit in order to avoid problems associated with their health and life. And we can describe this later. Also, you should investigate if there is a low clear ceiling height on the equipment size. The use of site inspections is used to make sure that the equipment dimensions that are included in the proposal will fit within the space that they assume it will fit in. As a result of a site visit, it may be necessary to request modifications. As time goes on, if equipment arrives damaged, we suggest you take pictures. Next slide, please. The selected equipment supplier's proposal should identify each component supplied or to be supplied, its electrical, physical, and mechanical characteristics, and a description including the purpose for each component. This may seem tedious, but it's the way to educate the end user that the RFP response will meet their objectives. The equipment supplier should provide a description of the services to be provided, such as when interactive training sessions are planned, a schedule for equipment startup, and a method to demonstrate acceptable performance. Interactive training, by the way, is the growing concept and best way to ensure that the individuals who operate the equipment, whether it be any kind of a purification system, are thoroughly knowledgeable about what happens when they work with the specific equipment or when they maintain the specific equipment. The systems supplier's proposal should identify what documents will be supplied. And if required by the regulatory agency, the equipment supplier's proposal should include the costs associated with preparing a report and engineering plans that may be required for submission to a regulatory agency. The equipment supplier's proposal may include the necessity for arranging transportation of all items from the assembly location at the supplier's location to the job site and hiring the installing contractor. If this is required, it should be included in the proposal. Next slide, please. Continuing on with the selected equipment supplier's proposal, you should verify after equipment delivery that all listed components have been installed as described and are listed on every drawing, graphic display panel, and in the instruction manual. I bring this to your attention again because I was involved in 2 different cases where that particular task was not verified. One system supplier sold and supplied their environmental control system to 2 different industrial end users in 2 different states. In each situation, the supplier was responsible for installation. The supplier did identify in each of the 2 proposals every item that was to be installed at each end user's facility. The system supplier outsourced the installation portion of their contract to a separate company, but they were responsible for the installation. The installing company neglected to install one identical critical item in each facility that had been received on site. But no one informed either the end user, or rather either end user, that the critical item, which was an inline static mixer, had not been installed. The result was the end user was fined for discharging wastewater that contained contaminants at a higher concentration than that allowed. The customer sued the supplier and the installation company. That's a situation that should not occur, and that's why I reemphasize that first item on that slide. In addition, the selected equipment supplier should verify that the operating manual, spare parts, and spare parts list and drawings will be available to appropriate end users' personnel. They should verify that tags are attached to each item, or at least are available to be attached to each item. Each tag number should be used on the bill of lading, such as the delivery documents, in the manual of operation, on the installation drawings, on the motor control panel, and any instrument or graphic panel, and on the process flow drawing. It's an easy way for the installers, the equipment users, and the equipment suppliers to identify a piece of equipment should a question occur. Next slide, please. The selected equipment supplier must provide detailed operating instruction manuals, including the design basis for all items supplied, operational procedures, training schedule, including that for the second and third shift of work. Included should be preventative maintenance guidelines. The required frequency for preventative and normal maintenance of equipment should be clearly spelled out. The supplier must furnish detailed process flow and plumbing drawings, which include the tag numbers. Detailed electrical power and instrumentation wiring drawings that should contain local disconnects and junction boxes where appropriate. The supplier must furnish vendor literature for all drawings for items such as pumps, motors, tanks, liquid level sensors, controls, valves, instrumentation process monitors, process recorders, and mixers. When hazardous, flammable, or toxic materials are stored or used in any facility, any of these end users' facilities, copies of material safety data sheets and the location where these chemicals are stored or used should be accessible to fire or emergency service providers arriving at the job site in case of a fire or other emergency. You may ask, what does a preliminary flow drawing look like? Next slide, please. This slide shows a preliminary process flow drawing that could be submitted to a potential client prior to the final equipment proposal. Specifically, this is a brief overview of the Tampa Electric Integrated Gasification Combined Cycle process. This process uses coal in a clean, economical, and environmentally efficient manner to produce electric power. Details, such as tag numbers, are not included in preliminary drawings, just the concepts. The process purifies coal to remove its sulfur content prior to burning. In this process, the coal is converted to a gas. Air used in the combustion process is separated into nitrogen and oxygen. The nitrogen is used to cool the turbine, and the oxygen is mixed with the gasified coal and then burned. The outcome is power production that requires 15% less fuel and achieves 10 to 12% more efficiency than normal generating stations. How could an equipment supplier verify to the end user that the installed purification system meets what was guaranteed? The next slide provides one process. While this may sound simple, it is not. Please let me explain. The verification process should ideally be repeated at various times under various conditions. A convenient opportunity to verify performance can occur at the startup. Another opportunity, such as applicable to an industrial manufacturer, can occur at different times when manufacturing is producing different volumes of material to be purified. The example on the slide states that a large quantity of sample will be collected. It should be split into 3 equal portions. The end user should receive one portion, the equipment supplier a second portion, and a third independent party, perhaps an independent laboratory, could receive the third portion. Each of the 3 portions should be analyzed by different laboratories. Next slide, please. A clarifier is designed to concentrate contaminants and have them settle to the bottom of a tank. This slide displays the general concept. The clarifier's efficiency to remove contaminants that are suspended in solution depends in part on the chemistry and the system hydraulics. As you see before you, there are 2, let's call them jars. The first jar contains untreated or unpurified material. The jar on the right contains the treated or purified material. Purified in the sense that the contaminants have been reduced in volume and have settled to the bottom of the jar. Next slide, please. Some environmental control systems require a large area. This snapshot shows a large environmental control system. The system is located in Batavia, Illinois. The installation process for these systems are expensive, especially if they're large municipal systems. Let's review a partial list of objectives for installers over the next 3 slides. Next slide, please. The installing contractor should review the job site prior to beginning an operation to determine if any new modifications should be made or assess if unanticipated risks may occur during installation. They should become familiar with the job site and how industrial equipment will be offloaded, positioned, and discuss any unanticipated employee safety and structural uses with the end user if they occur. They should assess any previously requested changes to internal infrastructure support systems that were not completed on time. The installing contractor should, of course, review all of the installation drawings with the end user and the equipment supplier. Next slide, please. The installing contractor should verify that tags are or will be attached to the equipment. They should verify that each tag number is also referred to in a bill of lading, the manual of operation, the installation drawings, the motor control panel, the instrument control panel, and the process flow drawing. They should document any materials or components that were not finished. An appropriate notification should be made to the equipment supplier and the end user. And an installing contractor should use their knowledge to discuss any inconsistencies with the end user for such items that may be missing, damaged, or defective. Next slide, please. The installing contractor observes before they begin that a modification of work will be required in meeting the building code. They should immediately notify the end user and request some type of acceptable change. They should review all changes to the supplier's final proposal in order to verify that they were included in the installation drawings. And lastly, they should inspect all equipment upon arrival at the job site for damages. Next slide, please. Briefly, this slide provides some indication of the responsibilities of independent contractors and subcontractors. All independent contractors should maintain a close relationship with the end user's safety department to reduce the potential for accidents. When a contractor is hired to operate a system, they may be approached by firms having newer technology that can reduce the cost of operation. The new technologies could include methods to recycle or recover materials and byproducts, other cost reduction steps, and methods to improve equipment performance. When operating systems, a contractor should maintain a list showing what and when maintenance was performed on each piece of equipment. That list should include recommendations for future equipment updating or replacement and events that occur each day. Next slide. In this last slide, I define some of the safety issues that should concern everyone involved. That starts with the end user, the equipment supplier, the installing contractor, and any independent contractors involved. Everyone concerned should assess the risks for accidents, and using engineering controls and proper labels may reduce that potential from occurring. The most common violations, as noted by OSHA in general industry, include chemical hazard communication, that's that word communication again, lockout and tagout of hazardous energy sources, respiratory protection, electrical wiring components, forklifts, and other industrial trucks, machines, and electrical design systems. A few final comments. The objective of this presentation is to provide insight to legal professionals for opportunities where you can assist your clients by providing proper environmental management of industrial equipment. In addition, this presentation includes topics and concerns that perhaps are unfamiliar to legal professionals that consume technical professionals during the life of an environmental control system. Thank you for your time today. Are there any questions?
Peter, thank you so much for your presentation. We do have a couple questions in the queue here, and if any attendees do have a question, please send them in. Tyler asks, if interactive training is the best way to train operators, would the use of standard classroom training be absolute and negligent and negligent to use?
Negligent to me is a legal term which I will not address. The way in which a teacher or instructor provides instruction to have the attendee in a training session participate in actual conditions is always subject to concern. To have just classroom discussions without having the operators physically work on the equipment may be unsatisfactory in the future. It has been found that the more active an operator can be during a training session, the more he will or she will learn what options are available when working with equipment and how to interpret results from analytical chemical laboratories. So classroom training is part of what should be done, but I think most of the literature coming out now prescribes interactive training, not just sitting on a computer and listening to a webinar. That may be insufficient to provide incentive for any employee doing work. They should be doing on-the-job training. In fact, at the job site would be most productive, in my opinion.
Okay, great. I don't see any other questions in the queue, so I'm going to wrap up this afternoon's program. Peter, thank you so much for your wonderful presentation. I think everybody who attended learned a lot from it. If you would like to speak to Peter about a case, you can contact us here at TASA. Our number is 800-523-2319. We'll be sending around a link to the archived recording of this webinar tomorrow morning. In that email, we will include a copy of the PowerPoint presentation. The archive recording will also be posted in the Knowledge Center on TASA's website. If you go to our website, tasanet.com, and click on Knowledge Center at the top of the screen, you'll be able to find all of our past presentations. Our next client-focused webinar, Slips, Trips, and Falls, will take place on November 1st at 2 p.m. Eastern Time. You should be receiving an invitation shortly for that program. If you have any follow-up questions or comments, please email me at mhyde@tasanet.com. We do take all of your comments under consideration, and they help us to put on better programs. On behalf of Peter and everybody here at TASA, I thank you for taking time out of your day to spend with us, and I look forward to seeing you at future TASA programs. Thank you so much.